Hello everybody. In today's video, we are going to talk about similar polygons. And similar polygons are different from congruent polygons in one major way. And we'll go over that right now. So, similar polygons are polygons with the same shape, but they're different sizes. If you remember back when we did dilations, when we dilated a shape, we were always creating two similar polygons because we didn't change the proportions of the shape, we didn't change the scale factor. All we changed was how big or small the shape was. So if you took it and you physically enlarged it or made it smaller, all the proportions stayed the same, but the shape got either bigger or smaller. That's what similar polygons are. They're either bigger or smaller versions of another shape, but in every other way, they're the same. Okay? So let's look at this. Polygons are similar if the corresponding angles are congruent and the corresponding sides are proportional. And we're going to go over an example here in a second on what that means. But basically, the angles have to be identical. They can't be, there can be no differences in the angles. The sides, they just have to be, the relationship between the sides or the sets of sides has to be the same on all three sides. And we'll go over that in a second too. So the ratio of corresponding sides is called the scale factor. Again, we talked about this when we did dilation. It's basically the ratio by which we are multiplying one polygon to create our similar polygon. And then if polygons are similar, then the perimeters are also proportional. This is just a side note. You can use this to help you in certain situations. So let's go ahead and get started here and look at a couple things. So it says, what is the scale factor of ABC to DEF? Now I want to show you that we can also prove that these two triangles, right? We have this triangle here, ABC, and then we have DEF right here. We can prove they're congruent. Well, first of all, we need to know that the angles are congruent, right? So let's see if we can prove that the angles are congruent. Well, fortunately, they kind of tell us, right? We have one that matches here and here. We have one that matches here and here. So B and E match. And then we know C and F match because they tell us, right? So as long as we have three sets of corresponding angles, so far so good. So now let's figure it out. We need to know that the corresponding sides, we know the corresponding sides are proportional. Well, that's where it takes a little bit of math. And now we have to deal with ratios, which is what we talked about in the last lesson, right? So what is the scale factor of ABC to DEF? Well, let's look at this real quick, right? AB is 8. So this is 8, and DEF would be 12. So we have 8 over 12, right? This is 8 to 12 is another way of saying it, like if we were talking about what we did the other day. Now, if we take this and we reduce this, right, we're going to get 2/3. All right, so far so good. So we did AB and we did DE because those were the corresponding sides, right? Now let's do another set. So I'm going to do 10 over, well, the corresponding set to BC would be EF, which in this case is 15. And if you notice, if we reduce this by dividing both by 5, we get 2 over 3. So far we have the same scale factor for both sets of sides. And if we can find the scale factor of the third, and it is indeed the same, it's 2/3, then these two triangles are similar because the sides are all proportional and the angles are all congruent. So let's go ahead and do the third side here. I'm just going to do it down here. We have 14 to 21. And if we divide these both by 7, 14 divided by 7 is 2. 21 divided by 7 is 3. And again, we have 2/3. So these are similar. Okay? And I'll show you how to write that they're similar here in a second. But if this question asks us here, what is the scale factor of triangle ABC to DEF? Well, ABC to DEF, we just did it. It's 2/3 for all of them. Right? And now let's look at the next question. What is the scale factor of DEF to ABC? Well, if ABC to DEF is 2/3, this means we're going from the smaller triangle, right, to the bigger triangle. So we're going from 2 to 3. Well, this time we're flipping it. We're going from the bigger one to the smaller one. So we're just going from 3 to 2, okay? And notice that it says over here order matters. It does because we go from the first triangle to the second one. So if we're going from a smaller one to a bigger one, our number should be less than 1, right? We have 2/3, and 2/3 is less than 1. But if we go from a bigger triangle to a smaller triangle, then it's going to be greater than 1, right? Because in a dilation, anything greater than 1 was an enlargement. It's the same concept, right? So here we have 3 over 2, which is essentially 1.5, right? And 1.5, of course, is bigger than 1. All right, now what's the ratio of the perimeter of DEF to ABC? Well, we said that it's also proportional. So we're saying that it should be 3 over 2, right? But let's just do this math just to figure it out, right? So we have 10 plus 14 plus 8. So that's 24, so that's 32, right? Well, 32 will be on the bottom, right? Because we're going from DEF to ABC. So then on top we have 12 plus 15 plus 21. That's 33 plus 15 is 48. And awesome. Now we can reduce this. If we, looks like 16, we can take out of both, right? 48 divided by 16 is 3. 32 divided by 16 is 2. So yes, again, we got 3 halves, right? So that kind of helps us prove the rule that that is correct. All right, so similarity statements. This, first of all, over here on the left, similarity statements, it says the symbol for similar is just a little swoosh. Looks like that. That means similar. Remember how congruent was, like congruent had this, right? Well, in this case, we just take away the equal sign part. So it's just literally that swoosh. All right, so write a similarity statement for the triangles above. Well, let's do it, right? It's the same exact concept, only this time we're not saying that they're completely identical in every way. We are saying that the angles are congruent and the sides are proportional. So in this case, we could just do it the exact same way. We can say triangle, right? ABC is similar to triangle. Well, in this case, ABC, right? DEF would be how we'd have to phrase this one because they have to go in this specific order, just like before, right? We have to make sure that the sides and the angles match up, just like before. So that's how you make the similarity statement. It's literally the same as a congruency statement, just with the little swoosh instead of the swoosh with the equal sign. It's literally the same thing. All right, so list all congruent angles and write the proportion that relates to the corresponding sides. So again, the cheat code to this is to just use this statement here to match it up for us. So if we have JKL, PMN, so JKL, P, M, N. Right? And now they don't even give us sides or anything. We don't need this anymore. Right? That's just more information than we need. So angles. Okay, we know angle K is similar to angle M. And angle J similar to angle P. And of course, angle L similar to angle N. All right? And then I'll do one of the sides and I'll let you figure out the others, right? So I'm going to say KJ, segment KJ is similar to segment, well, if it was KJ, now it's MP. And I'll let you try the other ones, okay? There's only 2 more. Excellent. So now we have number 2 and 3. I'll go over number 2 with you, let you figure out number 3 on your own. Okay, it's the same exact idea, right? X, Y, Z, R, Y, S. So X to Y to Z, right? R to Y to S. If you want to do this, you can. X is R. Y is still Y, right? It's actually shared by both triangles. And then S is actually the same as Z, so I'm going to put the S here, right? And now you can think of it as these are similar, right? This looks a little different because they're stacked on top of each other, but I'm just showing you that these are similar, right? So in this case, for our angles, we'd have like angle X is similar to angle R, right? And it's the same thing as before. And then for sides, I'll do one with you. I can say XY is similar to RY. Perfect. And that's really it when it comes to congruency statements, all right? Try and do number 3. We're going to do finding side lengths in the next lesson. So if you want to, like, remember that we're not doing this anymore, like, you can draw a line, like, right here. Like, this is where we're stopping. Okay? Awesome. So we'll do finding side lengths tomorrow. And that's it for this video. So I will see you in the next one.